Hey everybody, this is Dan Hewitt here in Mission Control Houston. I'm joined by Dr. Tara Rutley, and this is Mission Control. You're joining us here now. This is where we fly the International Space Station. This is where all the flight controllers are monitoring everything that's going on board as our astronauts are hard at work on maintenance and experiments and all kinds of things while they're flying 17,500 miles an hour. So welcome inside of Mission Control. It's really great to have everybody here. Tara and I are really excited to take some of your questions. So why don't we go ahead and just get started?
Thank you. Did you want to take our questions now?
Yeah, we would love to take any questions you guys have right now.
Okay, so you did not want to brief us on anything right now. We have time. We have lots of questions, so that's what you're telling us to do?
Yep, you got lots of questions. We want to get them all.
Awesome.
Hello, my name is Sebastian Miswit. Thank you for taking my question. What types of science experiments are the astronauts working on in space?
Very good question. That's the best question because that's what I really love to talk about the most. Right now they're on space station, right? And they do all kinds of science experiments. If you can think about, if you've ever participated in a science fair and you've done your science project, imagine what might happen if you take gravity out of everything that you've done. So imagine creating any kind of experiment that you could do here on Earth, but what would happen when you take gravity away? And
Make it a lot more fun, probably.
Yeah, it'd be a lot more fun. It would be much more fun than what I did as a student in my science fair days. But so what they do, and the number one coolest thing I think that they work on is the human research. They test their own bodies for changes that occur in microgravity or as a result of staying in space where things are just different. There's no gravity. If you think about how our body is designed, we have bones and muscles for a reason. That's to keep us upright against that gravity vector on Earth. But when you get out into space, you don't have that gravity vector anymore. So what they're finding is that our bones start to shrink. Our bones start to get weaker. Our muscles start to shrink. And so that's just one example of some of the changes that happen in the body. But our heart changes size because it's pumping fluids differently. So any system in the human body you can think of, they're doing experiments to figure out what's going on with the changes in space. Not just human physiology, though. They're also doing some basic physics work, looking at how fluid behaves differently without the gravity vector. You know, the way that fluid behaves here on Earth, again, that gravity vector drives a lot of how we drink out of a cup, how we water our plants, and how the plants will take up that water. So it's different in space where we need water systems. We need to understand how water behaves. In space, water tends to climb the walls of the containers that they're in, and that's called capillary action. And that happens on Earth, but in space it's much more pronounced because you don't have gravity pulling the liquid back down. So we're trying to figure out what happens to the fluids, and it's important for when you're creating things like propellant and water recycling systems and anything that has to do with any kind of fluid in space. And we learn much about how what happens in space, we can apply it to Earth in better ways to water our plants and things like that. They also, there's investigations that are looking and taking images of the Earth and of the space sky to look at changes in cosmic rays. There are experiments that are looking at how bacteria and viruses behave because they behave very differently, which has an impact on our crew. But it also tells us something about how the bugs treat us here on Earth as well. So I think just about every kind of discipline you can think of, if you have an interest in any kind of science or engineering, you could probably come up with any kind of thoughtful experiment that they are probably covering on space station right now.
Okay, definitely Tara's favorite question. All right, let's move on to the next one.
Thank you so much. Could I get both of your names? We have some media in here with us, and we'd like to share your names with our media. So could I get both of your names?
Yeah, sure. I'm Dan Hewitt, H-U-O-T.
I'm Tara Rutley. There you go. T-A-R-A.
Oh, and your name Tara?
Uh-huh.
Oh, there it is. Okay.
Yeah, on the screen. R-U-T-T-L-E-Y.
Okay. Okay, great. There we go. Okay, thank you so much. Yes, we have another question, Amarian.
Hi, my name is Amari Mitchell. Thank you for taking my question. Are there plans to take other vertebrates with the astronauts when colonizing another planet?
I didn't quite catch that question. Did you?
Are they going to take what with them?
Lauren, talk loud, a little bit louder. Gotta be loud. You did it great. You just need to do it louder. Say it louder.
Are there plans to take other vertebrates when the astronauts with the astronauts when colonizing another planet?
Oh, are there plans to take other vertebrates when the astronauts go to colonize other planets? You know what? That's a really good question. I think the only way to find out if that's really necessary or what we might learn from doing that is to try it out on the space station first. We don't know a whole lot about how vertebrates function in space. And so before we would take them or figure out how we would use them on a planet, we'd want to figure out how they even behave and react in space first. But that's a really good and thought-provoking question.
And we have had a couple of different types of animals already on board
That's
the
right.
station. We just had a couple of spiders return fairly recently from a trip on board the station, and they were able to adapt to microgravity and spin webs, and actually adapted really quite well
Yeah.
once they were up there. And actually, we also have another experiment going on right now where we have a bunch of tiny fish in a very specialized aquatic habitat. They're called Medaka fish, and they're up there to try and see any type of bone loss that they go through, because fish aren't as constrained by gravity quite as much as you and I are down here on Earth. So we have experimented with a couple of different types of specimens from the animal kingdom, but as far as anything like taking a dog with us to Mars or something, that might be something we do in the very distant future. But right now we're really not sure.
All right.
All right, great question though, really cool.
Thank you. We were doing research the other day, and in one of the first space flights, you took a dog,
Yes.
but I guess the dog did not survive, and so that stimulated their curiosity about other vertebrates.
That's right. They went before
Yep.
we did.
I think one of the first animal in space was a Russian dog known as Laika. And I mean, that was back when we were launching things, and it was very, very rudimentary, and we weren't even sure if any being could survive in space. So that was one of the first experiments that they did, and they sent up a dog.
Yep.
Go ahead, Madeline.
Hello, my name is Madeline Bernard. Thank you for taking my question. What types of experiments do astronauts like to do the most?
I think the answer to that is whichever ones they get to put their hands on. Which experiments do the astronauts like to do the most? I think most from when I talk to them, it's just whichever ones they can participate in, because you know, everybody has a drive for figuring things out that may not even be in their own area of interest. So we may have a scientist who's up there who has a background in human physiology or the human body, but how cool is it to be able to do flame experiments when flames behave differently in the microgravity environment? So it's my understanding, I think anyone that they can do themselves, because some of the experiments are automated and not all have to be done by the astronauts, but so they just like getting up there and doing any number of them.
Very good question.
Thank you. We just completed our biology unit, so we were studying genetic modification. I have a student with a question related to that. Christian?
Hello, my name is Christian Smith. Thank you for taking my question. Are you doing any research on genetically modified organisms in outer space?
Yeah, I think the coolest one that I can think of offhand is how bacteria behave differently in space. That's a really good question. And there are so many experiments on that, but the one I like the most is bacteria. And there's one that they have found that behaves much differently, and it's one that you and I can relate to, that makes you sick to your stomach. If you've ever eaten some food that has made you sick, the bacteria in that is called salmonella. One of those could potentially be called salmonella. And we found out that salmonella become more aggressive in space. They just become nastier. And scientists wanted to find out why. And so they they took some samples back that had flown on space, and they looked at them here on the ground in their laboratories, and they did find genetic modifications. One particular gene that became much more what's called upregulated, or much more active in affecting the behavior of those salmonella bacteria. Why that is, it's still hard to say. Some of the scientists think that because salmonella like to live inside your intestines, and your intestines are low fluid shear environment, or an environment that doesn't cause a lot of turbulence. It's just like what they grew in microgravity, where fluid it's not turbulent. It's also something called low shear. So they think that the microgravity environment is similar to what is inside of your intestine, and that's what makes these bacteria just upregulate that one gene that makes them more aggressive.
Okay, that is fascinating. Thank you. Isha has a question. Lately, our research has been focused on the planet, so we were wondering, and Isha came up with this question.
Hi, my name is Isha. Thank you for taking my question. What are we learning on the space station that will help us understand the solar system?
Awesome question. We have a couple of external, what we call payloads, a couple of external pieces of hardware that are outside on the space station truss, and they're scanning the skies for changes in cosmic patterns, things like changes in X-ray sources that could potentially identify some events that we've not seen before. For example, there's one payload called MAXI, and it registered a signature change in the sky that showed for the first time ever that it was an indicator that a star had gotten too close to a black hole, and the black hole started shredding the star. And so the X-ray events that came from that were picked up and measured by this MAXI payload, and it was the first time ever that astrophysicists were able to see something like that actually happening, because it had always been thought about, and they always thought it happened, but we'd never seen it before. So understanding what happens in our solar system, especially when you're talking about a star that might orbit too close to a black hole, says a lot about how we might venture out further. And there's also inside the space station, there's also a facility that is doing an investigation called GeoFlow, and they take the components of what they thought the Earth might have been made of in the very beginning, and they put it inside of this chamber that's a fluid chamber, and basically recreate the events of how we thought the Earth might have been formed. And the reason it's done on the space station is because it's microgravity. It's missing that Earth's gravity, and that's a critical part of how the Earth would have been formed. And so this is called GeoFlow, and it's being done by our European partners. And so when the information comes back from that, that'll advance our knowledge of how our own planet was formed and give us even further insights as to how other planets are being formed out there.
Thank you. You mentioned radiation, and one of our questions students have a question related to that.
Okay.
Hello, my name is Tom. Thank you for taking my question. Are the astronauts exposed to any types of harmful radiation while in outer space?
Another good question. So the vehicle itself, the space, yes, there's lots of radiation out in space when you leave the Earth's atmosphere, quite certainly. And so any vehicle or spacesuit that you create has to take that into account for crew health. And so the space station itself consists of material that works to shield the crew against the harmful radiation effects. And then also, in addition to the materials that are used, we have a number of radiation detectors, and a lot of different types of radiation detectors that are positioned all around the inside of the space station that can constantly tell us, sends the signal down to the Earth, so the scientists are constantly evaluating the radiation amounts that the crew are being exposed to. And so it's definitely a big health issue, and it's very real, and definitely there are lots of measures in place to try to protect the crew from that kind of exposure.
But the space station being where it is, it's only a few hundred miles off the surface, so it's still kind of protected. The thing that really protects us from radiation from the sun and intergalactic things is our magnetosphere. So the station's still close enough that it's really protected by that. but it's as soon as we decide to start going really far out, like when we want to go to Mars, that our astronauts will be a lot more susceptible.
Right.
So we're developing new methods on board the station for detecting and protecting, and those will be really important as we start to move, millions and millions of miles away from the Earth.
Yep.
Anna, thank you so much. You're speaking about radiation. Do they wear sunscreen? Do they have to worry about, getting too much of a tan?
I think that they actually have to. I don't think they get that, but they actually have to take vitamin D, increased vitamin D doses.
Yep.
But I think their spacesuits and all that protect them enough.
Yep.
Okay. Hey, very good. Anna, we have another student with a question about the experiences of gravity or the lack of gravity in outer space.
Okay.
Hi, my name is Anna. Thank you for taking my question. Since the astronauts are experiencing less gravity, how does this affect their skeleton or bone mass?
Oh yeah, really good question, and that's a number one thing that we need to work on if we're going to go beyond low Earth orbit and stay for longer out in periods in space, because you're not constantly working against the gravity environment. Think about all day. You stand, you sit, you walk, you climb upstairs, you use your muscles to get you around, and then in the microgravity environment, really they're just kind of floating around, and they can use their muscles to push off and get them where they need to go. And so definitely there starts to be it's use it or lose it. So if you've ever exercised and then you stopped, you probably can tell your muscles will start to get smaller, and it's the same with them. They'll lose some muscle mass and they'll lose some bone mass. But what they do on orbit, what they're finding is as they keep up with their exercise, they have very high resistive exercise that they do. It's similar to weightlifting. They have cardiovascular exercise on the treadmill that they do, and they also have a cycloergometer up there, which is a stationary bike. And with the combination of those three, and also eating the right kind of diets, and fish is a big one because it's got omega-3 fatty acid, which helps preserve bone. And if they eat all their calories, which is important for energy, and they take their vitamin D doses because they lack sunlight exposure, but vitamin D is important for bone. If they do all those things, then what we're seeing is we're able to maintain the bone mass. So the crew seems to not be losing as much of bone mass. And now one second thing we want to worry about with the bones is, although we may be maintaining bone mass in terms of minerals, what about the strength? We don't know much about the quality that's being maintained on the bone. So there's actually a lot more research that needs to be done on what's going on the inside of the bone. So we're keeping the bone mass there, but what's the structure like on the inside of the bone? Is it fragile? Is it brittle? Because if it is, then we could have issues with fracture, and we don't want to see hip fractures or bone fractures if we get all the way out to Mars or wherever we're headed. We get back on something that's a terrestrial environment that has some gravity vector. We want to make sure our bones are strong enough that we don't encounter breaks and fractures, and we want to make sure our muscles are strong enough to get us to be able to move around and carry the weight of our spacesuit and get us from point A to point B. So bone and muscle, in addition to radiation, are the biggest things that we need to overcome as humans and learn and understand to be able to get us out past low Earth orbit into the next level.
Wow, thank you. Speaking of breaking things, I have a question a student with a question related to potential breakages in outer space.
Okay.
Hi, my name is Will. Thank you for taking my question. What happens if the space station is hit by space debris?
Well, the first answer is always prevention, right? So we here at NASA are big on redundancy and prevention. So the first things that we are always doing is looking out ahead at the patterns of space debris that are approaching or anywhere near the space station. And so there's a whole group of people that's their only job. And so if we see something that might be getting a little too close, or something something we want to watch, then the teams on the ground here get together, decide on whether the crew should be alerted, and sometimes I believe we can do things to move the vehicle even, right, if we had to in extreme cases.
We have the ability to do things known as debris avoidance maneuvers, where we'll have thrusters either on a spacecraft visiting the station that'll then be fired, and they can actually raise the altitude and kind of get it up out of the way.
Mm-hmm.
And I mean, that's done for any object that we're able to track, and we can track very small objects while they're in space. But the other problem is there are a lot of very even smaller objects that we can't always track. The station will actually be, hit by dust-sized particles, which may not seem like much, but when you're traveling at the speeds you're traveling at, they can leave marks, they can leave dents, they can actually damage the station. If it were to actually be hit by something, there are a number of procedures in place so the astronauts would always be safe. They have spacecraft they could shelter in and come back down to Earth immediately. They can seal off different sections of the station with hatches. So there are things in place that should that ever happen and we don't catch it and maneuver out of the way in time, the astronauts would still be okay.
Oh, wow, great. So there's no chance of being hit by a orbiting planet. It's too big.
We'd see that one coming.
Okay, go ahead. We have a question related to planets.
Hi, my name is Caitlin, and thank you for taking my question. Are the astronauts able to see the planets from the space station?
Oh, that is a good question. I don't think so. Or maybe through
They
telescopes?
are every once in a while. We actually, I don't know if you guys followed when we did the big transit of Venus a couple of months back, but one of our astronauts was actually able to take photographs, and that was as Venus was crossing right in front of the sun, and we were able to see Venus very well through telescopes all over the planet. But our astronauts are able to see, and they can see them generally like you and I can see them, because again, they are in space, but they're only a few hundred miles away. And when you talk about planets, they're tens and hundreds and millions of miles away. So anything that they could see is really what you can see down here, maybe just a little bit clearer.
That's a good question.
Okay, interesting. Okay, thank you. Go ahead, Sequoia.
Hi, my name is Sequoia, and thank you for taking my question. What are some of the new planets recently discovered?
Yeah, that's a good question. I read something that came out just yesterday from NASA's Kepler telescope mission. And so if you're interested in how we're discovering new planets, I would check out the Kepler mission site. It seems like Kepler's been running since, I think, 2009. And so its sole job is to look for potential new planets or candidate planets. And I believe yesterday came out saying that there had been about 461 potential new planet candidates discovered. And I think of all of those lately, 4 of those are in what are called the habitable zone, or they're near the roughly a little bit bigger than Earth, but also have the potential to have water on the surface. So so that was really neat when I read that, and so you should definitely check out the Kepler telescope mission site.
And
we have time for one question. Oh.
Okay, go ahead. We have one related to that about new planet discovery.
Hi, my name is Kiana. Thank you for taking my question. Which planet looks to be the most promising for human habitation?
As of right now, I'd have to say Mars, wouldn't you?
I would agree. I mean, when you're talking about the planets in our solar system, the closest ones, if you're going to inhabit a planet with humans, it's got to be a solid planet like ours. The only ones that fit that are the ones in our immediate area. The issues with the other ones, Mercury, you're much too close to the sun, it's very far away, it's a lot smaller, it doesn't really offer everything, an atmosphere, things like that we would need. Venus is the exact opposite. It has such a huge atmosphere and so much pressure that if you were to stand on the surface of Venus, you would literally be crushed. And so we couldn't really inhabit that one. But Mars is basically kind of a miniature Earth. It doesn't have nearly the atmosphere. It's a very small atmosphere compared to us, and it doesn't quite offer the same radiation protection, but it's close enough and like us enough that that would be our best candidate to go and inhabit. But really good question. I think that's all the time that we have for today. But I really want to thank you guys for some pretty awesome questions today. Hope you enjoyed your time here in Mission Control with us, and maybe we'll hear from you guys again soon.
Thank you so much. We appreciate your time. Thank you so much.